Hello, how's everybody doing today? So, what I want to do was take a moment to go over how to add error bars for anybody that's interested in doing that. So, you have the spreadsheet that I put together with your raw data and then these descriptive stats that come with it. And I set it up so that you could just highlight this and create a graph if you like. Now, if you want to add error bars to your means that you graph, you have to set it up just a little differently. This is a quirk of Google Sheets, and there are limitations in Excel as well. But what you have to do in Sheets to make this work is sort of put your headers on two axes like this, and then you'll just have the appropriate values for your headers in the table. So I think I set things up so that if you insert your raw data into this sort of traditional part of the graph, then it should just populate in the highlighted section. So what you can do is go to the highlighted portion of the graph, just click and hold, and then drag and highlight these cells. So the yellow cells, you'll highlight those. And then we can go to the little icon for creating a chart. We'll click on that, and we've got a good start to this. Now, what we want to do is change this around just a little bit. Here, let me move this out of the way so we get a better title on things. So we'll go up to Customize. And when you go to Customize, we'll look at Chart and Axis titles. So in terms of a chart title, we can maybe look at the effect of hydrogen peroxide concentration on the mean, or on the, let's say, average time needed for paper discs to float. Okay. So, you can set that up however you want. But here we're just looking at how different hydrogen solutions, or hydrogen peroxide solutions, can make those little paper discs float. So we've got a decent title there. If we switch this, if under chart and axis titles, we go to horizontal axis. So there we have hydrogen peroxide concentrations. So that looks good. Then we can go back to that drop-down menu, and then we can go to the vertical axis. And then we just say time in seconds. So that looks pretty good. One thing I'd like to do just to sort of clean it up a little bit, I'll go down to where it says legend. And for that, for position, rather than auto, I'm just going to go none, and that gets rid of that legend at the top. Okay, so now here's where we have to finagle with things just a little bit. If you go to the series section, and where it says apply to all series, now that we've set things up the way we have, we can focus on just one series of data at a time. So we'll start with the 1.5% solution. So we have the 1.5% solution. If I move this over for just a second, the 1.5% solution was right here. And what I want to do is insert the standard error. The standard error just looks at how confident are we that the actual mean falls between the calculated mean. So the mean for the larger population would fall between there. So we've got the standard error calculated, the 6.03. So under series, I've got 1.5% solution. I'll click on the box for error bars. And then for type, we want constant. And for our value, we'll just put in our standard error, 6.03. So now, if we look at our graph, it's inserted the error bars, 6.03 above and 6.03 seconds below the mean. So that sort of gives us like a 95% confidence interval. Okay, our data in reality is going to fall between here and there. So we did that for 1.5% solution. Now let's look at a 3% solution. So again, under series, rather than apply to all series. We, in this case, we'll look at the 3% solution. When we scroll down to look at what we're going to add, we add the error bars. Again, for type, we're going with constant. Our standard error value that was calculated in this instance was 1.06. So 1.06. And then we're all done. So the beautiful thing is we've got this nice graph, labeled axes, good descriptive title. We have our means. And then if we look, those error bars don't overlap. So if the error bars don't overlap, then you know that there was a statistically significant difference between your groups or your trials. So that's a cool way to look at the data that you've collected and compare your numbers to one another and see if there is a significant difference. So if you want to go for it, I'd encourage you to try adding error bars to your graphs and see what you come up with, and that should help you with your data analysis. So then you can just take this graph and copy it and paste it into the lab summary, and you'll have a really nice looking graph to go with the analysis, the quantitative analysis you put to that. Well, if you have any questions, let me know. Otherwise, hope you have a great day and good luck with everything.